Hello friends, today let us see how to get started with the C programming language. Communicating with the computer involves speaking the language the computer understands, which immediately rules out English as the language of communication with the computer. In order to learn the English language, we must first know the alphabets of the English language. Then using these alphabets, words are formed, and from words sentences are formed, and from these sentences paragraphs are formed. Similarly, in order to learn the C programming language, we must first know the alphabets, numbers and special symbols which are used in the C programming languages, and then how using them constants, variables and keywords are constructed, and then using these constants, variables and keywords how and instructions are combined. A group of instructions then later on made to form a program. A character denotes any alphabet, digit or special symbol used to represent the information. This figure shows the valid alphabets, numbers and special symbols allowed in C language. Now let us see how to construct the constants, variables and keywords in the C programming language. The alphabets, numbers and special symbols when properly combined form constants, variables and keywords. Let us see what are constants and variables in the C language. A constant is an entity that does not change, whereas a variable is an entity that may change. In any program, we do lots of calculations. The results of these calculations are stored in computer's memory. Like human memory, the computer's memory also consists of millions of cells. The calculated values are stored in these memory cells. To make the retrieval and usage of these values, these memory cells, which are known as memory locations, are given names. Since the value stored in each location may change, the names given to these locations are called variable names. In this figure, 3 is stored in a memory location and a name x is given to it. Then we have assigned a new value 5 to the same memory location x. This would override the earlier value 3 since a memory location can hold only one value at a time. Since the location whose name is x can hold different values at different times, x is known as a variable. As against this, 3 or 5 do not change and hence they are known as constants. C constants can be divided into two major categories. One is primary constants and then secondary constants. Under primary constants, there are integer constant, real constant and character constant. Under secondary constants, there are array, pointer, structure, union, enum, etc. At this stage, we will discuss only primary constants, namely integer, real and character constants. For constructing these different types of constants, certain rules have been laid down, and let us see what are these rules. Rules for constructing integer constants. An integer constant must have at least one digit. It must not have a decimal point. It can be either positive or negative. If no sign precedes an integer constant, it is assumed to be positive. No commas or blanks are allowed within an integer constant. The allowable range for integer constant is minus 2147483648 to plus 2147483647. The range of an integer constant depends upon the compiler. For compilers like Visual Studio, GCC, it is minus 2147483648 to plus 2147483648, whereas for compilers like Turbo C or Turbo C++, the range is minus 32768 to 32767. Some of the valid real constants are shown in the figure, that is 426 plus 782 minus 8000 minus 7605. Now let us see the rules for constructing real constants. Real constants are often called floating point constants. The real constants could be written in two forms, fractional form and exponential form. Following rules must be observed while constructing real constants expressed in fractional form. A real constant must have at least one digit. It must have a decimal point. It could be either positive or negative. Default sign is positive. No commas or blanks are allowed within a real constant. The above mentioned real constants are valid real constants. The exponential form of representation of real constants is usually used if the value of the constant is either too small or too large. It, however, does not restrict us in any way from using exponential form of representation for other real constants. In exponential form of representation, the real constant is represented in two parts. The part appearing before e is called mantissa, whereas the part following e is called exponent. Thus, 0.000342 can be represented in exponential form as 3.42 e minus 4. Following rules must be observed while constructing real constants expressed in exponential form. The mantissa part and the exponential part should be separated by a letter small e or capital E. The mantissa part may have a positive or negative sign. Default sign of mantissa part is positive. The exponent must have at least one digit, which must be a positive or negative integer. Default sign is positive. Range of real constants expressed in exponential form is minus 3.4 e38 to plus 3.4 e38. In the above mentioned figure, 0.000032 is written as plus 3.2 e minus 5 and 41 crore is written as 4.1 e8 and minus 200 is written as minus 0.2 capital E plus 3 and minus 0.000032 is written as minus 3.2 e minus 5. Now let us see the rules for constructing character constants. A character constant is a single alphabet, a single digit or a single special symbol enclosed within single inverted commas. Both the inverted commas should point to the left. The maximum length of a character constant can be one character. The above mentioned characters are valid character constants. Now let us see about types of C variables. Variable names are names given to locations in memory. These locations can contain integer, real or character constants. In any language, the types of variables that it can support depend on the type of constants it can handle. This is because a particular type of variable can hold only the same type of constant. Example, an integer variable can hold only an integer constant. A real variable can hold only a real constant, and a character variable can hold only a character constant. The rules for constructing different types of constants are different. However, for constructing variable names of all types, the same set of rules applies. Now let us see about the rules for constructing variable names. A variable name is a combination of 1 to 31 alphabets, digits or underscores. Some compilers allow variable names whose length could be up to 247 characters. Still, it would be safer to stick to the rules of 31 characters. Do not create unnecessarily long variable names as it adds to your typing effort. The first character in the variable name must be an alphabet or underscore. No commas or blanks are allowed within a variable name. No special symbol other than an underscore can be used in a variable name. These rules remain same for all the types of primary and secondary variables. C compiler is able to distinguish between the variable names by making it compulsory for you to declare the type of any variable name that you wish to use in a program. This type of declaration is done at the beginning of the program. The above mentioned figure is the example of type declaration statements. It is always advisable to construct meaningful variable names. At last, let us see about the keywords which are used in the C language. Keywords are the words whose meaning has already been explained to the C compiler. The keywords cannot be used as variable names because if we do so, we are trying to assign a new meaning to the keyword which is not allowed by the computer. Some C compilers allow you to construct variable names that exactly resemble the keywords. However, it would be safer not to mix up with the variable names and the keywords. The keywords are also called reserved words. There are only 32 keywords available in C language. The above mentioned figure represents the 32 keywords. If you like this video, please like, share and comment about this video. Please subscribe to my YouTube channel Good Life. Thank you for watching and happy learning.